I'm briefly telling you about nanoelectronics. We'll learn about Samsung Exynos and planar structure and FinFETs and Intel 22 Xeon 1230 is filled with dielectric RMG. RMG is replacement metal gate, and so is high-K material to use to end self-aligned contact. And this figure is to defect to the PMOS. And so epi growth and epilateral growth limit by shallow the thing. And Intel 14 nanometer Broadwell doing this figure. And this figure is to the NMOS and PMOS. The last picture is PMOS epi not consistently merged and location dependent, and NMOS is constantly merged, so location independent. And this is the end of this PPT. And we learn to the nanoelectronics to the tunnel diode. Tunnel diode to the equal to Esaki diode. Esaki diode is negative differential resistance to NDR, which means when the voltage is increased, the current through in the decrease. And we call to the degenerate semiconductor. Tunnel diode is electron in tunnel through the thin barrier. So we have the diode to reverse bias to easy to tunnel diode. And IV characteristic of thermal diode in the thermal equilibrium, and the Fermi level is to the constant, and small forward bias to the current is lightly increased, and forward bias until maximum tunneling, and Fermi level to the over the conduction band is Fermi level. The other side is to the below to under the valence band. And the forward bias after maximum tunneling current is to have to negative resistance. Forward bias after valley is no tunneling current, diffusion current start growing. So its electron and carrier is jump up to the other band. And under reverse bias, this figure is to peak and valley to the IV characteristic. IV characteristic of tunnel diode is I have to normal diode current and tunneling current and excess current to summing to this factor. And this is to resonance tunneling diode. Resonance tunneling diode is zero bias and threshold and resonance and off resonance. And this is the end of this briefly lecture. Thank you.